Alright, now in our previous video we looked at how to derive these equations, but in this video now we are going to look at how to apply them. That is the equations of linear motion. So we have our example 1 here, and in our example 1 we've been told a body is uniformly accelerated from rest to a final velocity of 100 meters per second in 10 seconds. Calculate the distance covered. So in this question we are going to calculate the acceleration first, then now we use the second equation to find the distance covered. So here acceleration A will be given by the final velocity minus the initial, and initially it was accelerated from rest, so it means that the initial velocity is 0. So here V minus U over T, where V is the final velocity minus the initial divided by the time taken. So acceleration A will be V 100 meters per second minus U, that is from rest 0, divided by the time taken, which is 10 seconds. So here 100 minus 0 is 100, divided by 10, we get 10 meters per second squared. That is our acceleration. We now move to calculate the distance. Distance will be given by the second equation, where displacement is given by ut plus a half at squared, where a is our acceleration, u is the initial velocity, which is at rest, that is 0. So here it is at rest, so u equals to 0. So s, that is our distance, is ut, which is 0 times 10 plus a half. Acceleration is 10 multiplied by the time squared, which is 10 seconds, so 10 squared. So here we'll have s equals to 0 times 10 is 0, plus a half times 10 times 10 squared. 10 squared is 10 times 10, we have 100. So here 2, 1, this one is 5. So 5 times 10 squared will give you 500. So our distance here will be 500 meters. That is how to use the second equation, whereby you are going to use it to calculate the distance. You first of all find acceleration, then you apply that acceleration there. We now move to example number 2. In example number 2, we have been told a body whose initial velocity is 30 meters per second moves with a constant retardation of 3 meters per second squared. Calculate the time taken for the body to come to rest. So here, for the body to come to rest, it means that V will be finally 0. The body is decelerating, it is reducing its velocity. So here, our retardation here will be our acceleration, but it is negative acceleration, but it is negative. So it is negative 3 meters per second squared. And then what else do we have? Velocity. So initial velocity u equals to 30 meters per second. Now here, after looking at this question, we are only required to calculate time, and we've been given the final velocity and the initial velocity and acceleration. So we are going to apply the first equation, whereby the first equation is V equals to u plus at, where v is the final velocity, u is the initial velocity, a is acceleration, and then we are required to calculate t. So here our final velocity is 0 because it comes to rest, equals to the initial velocity, that plus our acceleration, it is in the negative direction, so it will be minus 3 times t. We find now t here, so 0 will be equals to 30 minus 3t. We take this 3t to the opposite across the equal sign, so we have 3t will be equals to 30. So 3t equals to 30. We solve this one, we divide both sides with 3 divided by 3. So our time here will be equals to 10 seconds. That is the time that was taken for the body to decelerate from the initial velocity, which is 30 meters per second, to the final velocity, that is 0. That is the body comes to rest after 10 seconds. So those two are the simple examples that on how you can apply the equations of linear motion. In our next video, we are going to look at the horizontal motion and also the vertical projection. Please subscribe and like this video.